In this video lecture, I'm going to be discussing C++ classes and inheritance. If you're familiar with these topics, you can rapidly scan through this video. Even if you've seen it before, there's often a couple things in this lecture that I found students don't necessarily know, such as why you should use initialization lists in C++, or how you can call constructors for superclasses. So it's worth taking a look. If you're looking for references for this lecture, Chapter 9 of the Scott book has good information, not just on C++, but other inheritance. Any good C++ book should have a chapter or two on C++ classes on inheritance. And my old CS302 notes have some sets of lecture notes on various C++ classes and inheritance and features of them. So first, a quick review of classes. Hopefully you remember that you typically are going to put your So we're going to start with a quick review of classes, and hopefully you remember that in C++ you typically have two types of files. .h files where you have your class declarations, and .cpp files where you have your implementations. So you'll typically, with a C++ class, you start with the keyword class, for example, class stack. And then you have three types of access modifiers. You have protected, private, which is the default access modifier, and public. And with each of them, you just use the keyword once, followed by a colon, and then the list of variables that go with it. Okay, and then you have to remember to put a curly brace and semicolon at the end. So this is what would go in your .h file. In your .cpp files, you'd put your method implementations. And if you remember, you have to prefix your method implementations with the name of the class. So I'd have to say int stack : pop in order to provide an implementation for the pop method. So that's a pretty rudimentary review of C++ classes. Let's go on to constructors, equal operator, and destructor. So you may remember that there are two types of constructors in C++. There's a type that gets called when you either allocate an object off the heap using new, or when you allocate an object off the stack. So for example, if I were to say stack S, then I would get a normal constructor. There's also something called the copy constructor, and it copies one instance of an object to another instance. So there's three times you use the copy constructor. One is if you say stack S, and we have stack, say, y equals S. So when we initialize a stack to another stack, the copy constructor gets called. Similarly, if we wrote stack y of S, that would also invoke the copy constructor. So initialization is one instance when we use the copy constructor. We also use it when we pass an object by value, which we typically should not do, but if we do pass an object by value to a function, so for example, if I had written copy stack stack S. This would be very inefficient, but this would invoke the copy instructor for S. So that's one, that's two, and the final thing is when we return an object. From a function. And if you remember, the form of a copy constructor is special. It is, if you name it, in this case we're stack, then the form is going to be stack with a single parameter const, very important to declare it as const, stack, and a reference. And that tells the C++ compiler that you are creating a copy constructor. If you leave off the const, it will think that it is a regular constructor, not a copy constructor. And remember that with copy constructors, you need to be careful to duplicate pointer allocated memory. So you don't just want to copy pointers. If I had, as part of my stack declaration back here, if I had said in the protected part, say int data, then when I called the copy constructor, I'd want to be very careful that I created a new data array and then copied the elements of data to the new data array. It would be very bad if I created just a pointer to this data, because now I'd have two stacks pointing to the same data array. So with copy constructors, you need to be very careful that you duplicate heap allocated memory rather than just creating pointers to it. In addition to the copy constructor and the constructor, there are two other closely related things. We have the destructor. And if you remember, that's simply the name of the class with a tilde in front of it and no parameters, and it gets called when you deallocate. So it's called when the object is deallocated. And this could occur either because we call the delete function or operator to delete a heap allocated object, or because a function's returned and the stack allocated object gets reclaimed. Finally, we have operator equal, the assignment operator. And there's often confusion between the assignment operator and the copy constructor, which is why I bring it up. So first of all, let's just quickly give you the signature for the equal operator. It is going to be returning a reference to whatever class it is, and then operator equal. And just like the copy constructor, it must take a constant reference to the class. And just like the copy constructor, it should take pains to duplicate heap allocated memory rather than just creating a copy of it, or I'm sorry, creating a pointer of it. And the reason you often get confusion is in these two cases. What gets called if you say stack S equals Y versus S equals Y? Well, in case one, the copy constructor gets called because it's an initialization situation. Case two, the assignment operator gets called because it's an assignment operator. So you have to distinguish between these two cases. They also come up with initialization lists. So you probably remember that when you declare a constructor, let's give it a couple things here. Let's say we have int size, and for the time being we'll just make it int size. you can do this, and you can say, for example, max size, if max size is an instance variable, size. And that will initialize max size to be size before you even go into the constructor. Alternatively, you could just say max size equals size. And no one may have ever told you that there's a difference in efficiency between initialization lists versus doing the initialization inside of the constructor. And the difference is this. If you use an initialization list, so initialization list, then if you're passing an object, only the copy constructor gets called. Versus when you do it in the constructor, where first the zero argument constructor gets called, and then the assignment operator gets called. And you may not think that you would often be passing things by value, but you often pass strings by value. You often pass small objects like, say, a point by value. So it actually does come up where you pass things by value. And to just show you this, I have created a small example. And you can see that I have just declared a rudimentary stack. It has a zero argument constructor, a copy constructor, and an assignment operator. And I've declared a class foo that takes a stack as an instance variable. And in the constructor, you can see that it takes a reference to y, and then it's going to initialize x to by. So even if I'm passing y as a reference parameter, there's going to be a difference. And down here, I have in my constructor, I'm putting cout statements to tell me when I'm in my constructor, when I'm in my copy constructor, and when I'm in my equal operator. And I have in main just declared a stack B and then created an instance of foo called Z, and I have passed it B. So if we run foo down here, you can see it says in the constructor. That's the call that was made for B when it was created. And then when we passed B as an argument to Z, the copy constructor gets called. And that's because, if you remember, we used an initialization list. So the copy constructor gets called. Let's change it to see what happens if I now don't use an initialization list. So I'm going to say x equals y and compile it. And when I run it, you now see that the same in constructor is there for B, but now it called in constructor and in equal operators. So the constructor got called, zero argument constructor got called to initialize this x. Okay, so it initialized x before it ever called the constructor. Then when the constructor got called, this assignment operator executed and the equal operator executed. So the bottom line is it's better to use initialization lists when possible because they are more efficient. No matter what you do, your variables will be initialized before you enter the constructor. And if you have not initialized them explicitly, then they'll be initialized using a zero argument constructor. That concludes our rudimentary review of classes. Let's now look at how you do some inheritance in C++ and look first at how you declare a subclass. So let's say that we had a class fruit, and the way we declare a subclass, let's make it be apple, is by putting a colon and the name of the class, which in this case is fruit, the superclass, and then there's some kind of protection, which for the time being we'll just use public. That means that it inherits the API and the implementation of the superclass. That's it. That's what allows you to declare a subclass. Okay, now we also talked about virtual and non-virtual methods in inheritance, and by default in C++ methods are non-virtual. So methods are non-virtual by default. Remember, what that means is that if I have a declaration like fruit f equals new apple, and I call some method like say print type, then if I have not declared print type to be virtual, we will be using the print type method for fruit, not for apple, because by default the methods are non-virtual. So let's say we did want to declare a method virtual. What do we do? Let's go back here for a moment to class fruit. What we do is we would say virtual, use the virtual keyword, and then say void, in this case print type. Now if I do it like this, the C++ compiler still expects me to provide an implementation for print type. So we're allowing the subclass to accept that implementation or to override it. If I want to force the subclass to override it, then I can declare it as a pure virtual method. And I do that by saying equals 0. And that tells the compiler that there is no method body, do not look for one, and that every subclass will have to provide an implementation or that subclass will be abstract. Same thing with fruit. Fruit has become an abstract class because one of its methods is pure virtual. You do not have to declare fruit to be abstract like you did in Java. In fact, it would be an error. There's no such keyword. As soon as you declare something pure virtual, the C++ compiler knows that it is an abstract class. And let's just do a couple quick demos with another class that I've prepared called virtual.cpp. And you can see here I have a print type method for fruit that prints fruit, and I have actually overridden print type in apple, but because I did not declare print type as virtual in fruit, we're going to see that no matter if we declare a variable to be of type fruit, which is what we do here, then no matter what object we assign to it, it will use the print type method for fruit. So I've created an apple object and assigned it to my fruit pointer, another apple object and assigned it to my apple pointer, and then down here I've print type for both of them. And if I run it, you can see that fruit gets printed out for the first print type. And the reason is that even though apple provided a new declaration for print type, because print type is non-virtual, it still used the fruits method. Now the second time it really did print out apple down here, and that is because now we had a actual variable of type Apple, and therefore it's going to use Apple's print type. Also note this would not work in Java. If you tried to provide a override of print type in Apple, you would get an error in Java if it was declared non-virtual up in the superclass. Remember, in Java, you would do that by saying final. And the Java compiler at this point would give me an error. Not so C++. It's fine with you overriding a non-virtual method. It'll only use it, however, if you have an object of that type. Now let's actually declare print type to be virtual, and we will recompile virtual and run it. And now you see it printed Apple both times, even when we printed print type for F, because now it's a virtual function. The final thing I'm going to do is I'm going to actually declare it 0 to be pure virtual. And we will try to compile it and run it. And that worked for Apple because it, so we will recompile it and run it. And all is well. It produces 2 apples, and that's fine because even though fruit is a abstract class, as long as I assign a concrete subclass to it that implements all the methods, I'm fine. However, if I try to assign a fruit here, I should get an error message. Indeed, it says error allocating an object of abstract class type fruit, unimplemented pure method, virtual method print type. So it is okay to assign a concrete object to an abstract type. So here it was okay to declare a variable of type fruit, but we had to assign it an instance of a concrete object. Final thing we're going to talk about is the order of constructor calls. So when I create an instance of Apple here, actually what would happen? Which constructor would be executed first? The one for Apple or the one for fruit? So the order of constructor calls is that they proceed from the leaf, or from the root rather, they proceed from the root to the leaf. So let's say I had the order fruit, let's say I had a subclass called orange, and from that let's say I had navel orange. And I created an instance of navel. Well, what happens is before the constructor for navel gets called, it's going to call the constructor from orange. But that's going to cause a constructor for fruit to get called. So the order that they'll execute in is the constructor for fruit, then the constructor for orange, and then the constructor for navel. And that ensures always that the superclass's variables have been initialized before the subclass's constructor is called. And if you want to call a specific superclass constructor, you do so in the initialization list, and you explicitly name the superclass, and then you provide your arguments. And C++ determines which constructor you want by the number of arguments and their types. Remember, in Java you use super to call the superclass constructor, but in C++ you have to explicitly give the name of the superclass. And you do that in the initialization list. If you fail to do that, it will automatically call the 0 argument constructor for the superclass, and if that doesn't exist, you will get an error message. That concludes this review of C++ inheritance and classes. We'll discuss C++'s multiple inheritance mechanism in a separate lecture.